All right, so I'm going to refresh on how to find the exact value of any trig function whose either coterminal to 0, 30, 45, 60, 90, 180, or 270 degrees, or at the very least has a reference angle of 30, 45, or 60. So these are their own category of angles. We're going to call these the reference angles. So we're going to go over these first. And you only really need to know the table for sine and cosine from 0 to, you really only need to know sine of 0 to 90, which should automatically let you know cosine from 0 to 90, and the other ones can be calculated yourself. So I included them on a table, although we're not really going to go over, we'll go over them, but we don't need to go over them. All right, so we'll be going over some of them just for the sake of understanding how things work. So firstly, if you have a reference angle, that means you have a point. Your angle starts at 0 and then rotates to a point on the triangle and forms, it rotates to a point on the unit circle. That point is cosine sine. That will be important for later. All right, and it will form a right triangle with the x-axis and the terminal side. The angle formed between those two rays is going to be the reference angle. Okay, now another example would be in quadrant 2. So this would be like if you were given the angle 40 degrees. This would also be equivalent to being given the angle 400 degrees because it would be a full loop around as well as another 40 degrees. So for instance, let's say I had an angle over here and it was at 130 degrees. That means I start at 0, I rotate around to the 130 mark. I will then make a triangle with the terminal side, that's this side pointing at 130, and the x-axis, and the angle inside here would be the reference angle. So in this case, in the first case, our reference angle was 40, because it's always the angle in the acute the acute angle in this triangle here. So from 30 to 180, this distance is actually going to be 50 degrees. So this would be a reference angle of 50 degrees. And the reference angle in the triangle down here, if we were to call this endpoint 246, distance from 180 to 246 would be 66, making this a 66 degree reference angle. I'm just making up numbers, so hopefully it's as clear. If I were to write a point here and say this point was 297 degrees, and being that this is 360 degrees, the distance from these two is 63 degrees, so that makes this reference angle 63 degrees in this triangle here. So the reference angle is always going to be less than 90. How you find it is somewhat variant on where it is. So in the case of an angle in quadrant 4, it was 360 minus the terminal side. If it was in quadrant 3, it was actually the terminal side minus 180. If it was in quadrant 2, it was actually 180 minus the terminal side. And if it was in quadrant 1, it's just the angle in quadrant 1. So it's really the terminal side minus 0. So there's no real formula for that. You'll have to look at the angle more precisely for that. But there are some common values for our tables we need to know, which are from 30, 45, and 60. So we're going to come up with those numbers now. So there's two ways to do it. One way is more exact as to where it comes from. If we start with an equilateral triangle with all three sides measuring 1, we can split this into a 30, 60, 90 right triangle. I'm actually going to erase this side of the triangle, and I'm going to draw the unit circle around this triangle. So I've left the hypotenuse as 1. Now, the triangle doesn't quite reach the edge here, and it doesn't quite make it to the top either. So this point is going to be, since this is a 60 degree angle, this point's going to be the coordinate radical it's going to be 1 over 2 radical 3 over 2, but let's figure out how to find that. So firstly, the base of this triangle is going to be 1/2 because we split 1 in half because it was a 1 by 1 by 1 equilateral triangle. So this was 1, so I cut it in half, so it's a half. So now if we need to find the remaining side over here, we can just use the Pythagorean theorem. So 1/2 squared plus x squared equals 1. We'll get that. I'm going to work upwards here just so you can see a little better. So we're going to get 1/4 plus x squared equals 1. If we solve that, we get x squared equals 3/4 by subtracting the 1/4 to the other side. And by square rooting both sides, we get x is equal to, x will equal radical 3 divided by radical 4, which is 2, if we square root both sides. So this side is radical 3 over 2. And this number, that radical 3 over 2, and this 1/2 is going to determine a lot of the values in this problem. So because the hypotenuse is 1, the sine of 30 will be 1/2 divided by 1, or 1/2. So the sine of 30 is going to be 1/2. The sine of 60 is going to be across from 60, which is radical 3 over 2, which is where this number comes from. Now for the cosine, we look at the adjacents. So the adjacent to 30, if I'll use green for this, the adjacent to 30 is radical 3 over 2. And the adjacent to 60 is going to be 1/2, so next to that. So that's where all these values come from. It comes from this triangle. Now 45 isn't in this triangle, so we have to make a separate triangle for that. So I have another triangle here. We're going to label the side measurement of the hypotenuse as 1. We're going to draw a unit circle once again. So these sides are the same because of the base angles being the same. So we're going to say x squared plus x squared equals 1 squared by the Pythagorean theorem. Excuse me. We're going to get 2x squared equals 1. By dividing both sides by 2, we get x squared equals 1/2. And by taking the square root of both sides, we'll get x squared, x is equal to 1 over radical 2. Now, if we then were to rationalize the denominator, putting a radical 2 on the numerator and denominator, this will become x equals radical 2 over 2, which is what you should remember for 45 degrees. So that makes this side radical 2 over 2, and this side is also radical 2 over 2 in the 45, 45, 90 triangle. So its opposite side is radical 2 over 2, so that's the sine of 45. And the adjacent, which is to the is next to the 45, is also radical 2 over 2. So that's where these values come from. And all the other values can be found based on that. So if I want to find the tangent of, let's say, 30 degrees, I would take the tangent is going to be equal to sine divided by cosine. I can just divide those two numbers. So if I want to find that, I'll do 1/2 divided by, I'll write it bigger. So 1/2 divided by radical 3 over 2, which is going to be equal to 1/2 times its reciprocal, so 2 over radical 3. The 2's cancel out. We're left with 1 over radical 3. And by multiplying the top and bottom by radical 3, this will simplify to become radical 3 over 3, which is the tangent of 30 degrees. If we do the same thing for 45, we get radical 2 over 2 divided by radical 2 over 2, which is just 1, because this will just be it divided by itself. And if we do for tangent of 60, I'll get tangent in the table as well, we're going to get radical 3 over 2 divided by 1/2, which is going to become equal to, which is going to change to be radical 3 over 2 times 2 over 1, where the 2's cancel out, leaving us with radical 3. So we now have the sine, cosine, and tangent of 30, 45, and 60. And that's kind of how you find the tangents. Now we're going to talk about the quadrantal angles, and we'll talk about cosecant, secant, and cotangent when we do an example in a minute. For the quadrantal angles, those are angles that don't have reference angles. So they're the angles that you can't make a triangle with them. So for instance, 0, 90, 180, and 270, you can't make a triangle if your endpoint is 0, because 0 is just a flat surface. So we're going to start with 0. You'll notice the coordinate on the unit circle is 1, 0. And as we mentioned before, the coordinates are just going to be the cosine value and the sine value. So if we just go around the circle, where the x value is always cosine and the y value is always sine, we get all the values. So the sine of 0 is 0, because we can see that right here. The cosine of 0 is 1. If we go to 90, the cosine is going to be 0, and the sine is going to be 1. If we do 180, the cosine is negative 1, because that's what the x value is. The x value is cosine, and the y value is sine, which is 0. Then for 270, the x value is cosine, so that's 0. And for sine, it's going to be negative 1. And to find the tangent, we're just going to do what we did a moment ago, using that sine over cosine. So that is the sine of 0 divided by the cosine of 0 is going to be equal to 0 divided by 1, which is 0. We can do the same thing for 90, so it's going to be the sine of 90 divided by the cosine of 90, which is going to be equal to 1 over 0, which is undefined, so we'll just write undefined here. And for 180, we're going to get 0 divided by negative 1, which is 0. And for 270, we're going to get negative 1 divided by 0, which is undefined. So we now have all the values for the sine, cosine, and tangent. So the quadrantal angles will be anything that ends on an endpoint rather than forms a triangle. So let's take a look at the examples down below. So let's take a look at number 2, which is to find the sine of 450. Well, first step is you have to find the coterminal angle between 0 and 360. In other words, start at 450, and we're going to keep subtracting 360s until we get between 0 and 360. So if I subtract 360, I'm going to get 90. So 90 is between 0 and 360. So this is going to be the same thing as finding the sine of 90, mathematically equivalent. So the sine of 90, if we look at the graph here, is 1. The cosine of 90 was 0. Again, just looking at the values. The tangent is the sine divided by the cosine, so 1 divided by 0, which is going to be equal to undefined. The secant is the reciprocal of sine, so just to remind us that, I did these backwards. It's cosecant first, because cosecant is a reciprocal of sine, and secant is a reciprocal of cosine. So, just as a reminder, the cosecant is the reciprocal of sine, so 1 divided by sine. So this is going to be equal to 1 divided by the sine of 90, which is 1, so that's also going to be 1. The secant of 450 is going to be 1 divided by the cosine of 450, so that's 0 in this case, which is going to be undefined. And the cotangent of 450, there's a couple ways to look at it. I'd recommend looking at it this way. Just like tangent is sine over cosine, cotangent, because it's the reciprocal of tangent, is going to be cosine divided by sine. So the cosine was 0. Divided was, hold on. The cosine would be 0 divided by the sine, which is 1, which is going to make this 0. All right? And that's that. So if it's a quadrantal angle, it's not so difficult. You just need to be able to look at the values. So if I were to just change the colors just so you could see a little better, divide, divide, divide. All these values come from above, so this is really 1 divided by 0. So once you know the sine and cosine, you can actually find the tangent by dividing those. You can find the cosecant and secant by putting them over 1 and simplifying. Now, let's do for 480. Now 480 is different because 480 is not a quadrantal angle, it's going to have a reference angle. So if we look at the circle, because it's important to always know where these angles are, 480 minus 360 is going to be 120, so that means that 480 is really the same thing as 120 on the graph. So if we were to draw that angle, that would be over here somewhere. The reference angle is going to be formed over here. So this is 180, this is 120, so the angle between them must be 60. So this is 60. And the other thing we need to discuss is that an angle in quadrant 1, all the trig functions are positive in quadrant 1, but only sine and sine and its reciprocal, cosecant, are positive in quadrant 2. In quadrant 3, it's tangent and cotangent. In quadrant 4, it's cosine and secant. So that means we're going to rewrite each of these based on their signs. So we're going to call each of these. Now I'm just doing all of them so you can see them all. So this is going to be, so we're in quadrant 2. So sine is positive, and its reciprocal cosecant is positive, but all of the other trig functions are negative. So if you were asked for anything other than sine or cosecant, you're going to get a negative value. And then we're going to rewrite this as the sine of the reference angle, which is 60. So this is going to be cosine of 60. This is going to be tangent of 60. This is going to be cosecant of 60. This is going to be secant of 60. And this is going to be cotangent of 60. Now, we have most of those values on our table. So that means that the sine of 480 is going to be equal to positive radical 3 over 2, whereas the cosine of 60 is going to be negative 1/2, because the cosine of 60 is 1/2 and it's negative. For 480, it's going to be equal to negative, because tangent is negative in this quadrant, radical 3. And those are those values. Now, if I wanted to find the cosecant, the secant, and the cotangent, I actually have to take the reciprocal. So I'm going to do that on the table instead. You can complete the table if you want, but there's no reason for us to have to actually find the rest of the table. So for 60 degrees, it's going to be 1 divided by 1 divided by radical 3 over 2. So this is not a fraction divided by a fraction, so I'm going to make it into 1. I'm going to do keep change flip. So that's going to be 1 over 1 times 2 over radical 3, which is going to be equal to 2 over radical 3. And then I'm going to rationalize the denominator. So this is going to become 2 radical 3 over 3, because the 2 radical 3's are going to simplify into a 3, and the 2 and the 3 don't simplify any further. I'm going to do the same thing for secant. So this is going to be 1 over 1/2. I'm going to make this into a fraction. So this is going to become 1 over 1 times 2 over 1, keep change flip, which is going to be equal to 2. So for cosecant of 60, I'm going to get positive 2 radical 3 over 3. For secant, I'm going to get negative 2. And for cotangent, I have to come up with a value for that. So for cotangent, it's going to be the cosine divided by the sine. So that's going to be the cosine was radical, it was 1/2, divided by the sine, which was radical 3 over 2. If I keep change flip, that's going to be 1/2 times 2 over radical 3. The 2's cancel out, and then I'm going to rationalize the denominator. And I'm going to get radical 3 over 3. So this is going to be equal to negative radical 3 over 3. So depending on what you're asked for, you can get all of the values. All right, so hopefully this was helpful. I'll just pick another problem just for an example from the back. Eeny, meeny, miny, mo. Let's just do number 23 as an example. So for number 23, I would look at the graph, and 225 degrees is somewhere over here. So it's not a quadrantal angle. So we're going to have a reference angle here between 225 and 180. So this measurement is 45 degrees. So this is the same thing as fine, and so this is going to be, we need to know the sign of the value in this quadrant. So all students take calculus. T goes with tangent and cotangent. So this is going to be negative cosecant of 45 degrees. Okay, so this is going to be the negative of 1 over sine of 45 degrees. So this is going to be the negative of 1 over, the sine of 45 degrees is radical 2 over 2. And we're going to do keep change flip, so I'm going to make this over 1. We're going to get 1 over 1 times 2 over radical 2, and there should be a negative out front here. So this is going to simplify to be negative 2 over radical 2. Now I need to rationalize the denominator. So I'm going to multiply by radical 2 and radical 2. And I'm going to get negative 2 radical 2 over 2. The 2's will cancel out, and I'm going to get negative radical 2 as my final answer. So that's the full step-by-step process for this particular example. So as long as you know your table for the first few values, the rest of this becomes a lot easier, specifically if you know these values. And let's pick one more. So let's say we'll do negative 600. So if we look at the graph, negative 600 is kind of harder to find. So I want to be very careful when looking for it. So I'm just going to go around the circle. So this is 0, negative 90, negative 180, negative 270, negative 360, negative 450, negative 540, and then this would be negative 630, meaning that negative 600 is going to be somewhere over here. So negative 600. The reference angle is down here, though. So this is our reference angle. So I'm looking for the distance between negative 540 and negative 600. So that's 60-degree difference. So this is going to be, so before we can write this down, we need to know, whoops, uh-oh. Let me open that back up. Didn't mean to close that. All right, so continuing. We need to know what quadrant this is. So by all students take calculus, we know that tangent is only positive in quadrants 2 and 3. So we're going to get a negative cotangent of 60 degrees, because that's the reference angle, which can be rewritten as negative cosine of 60 over sine of 60, which can be rewritten as negative 1/2 divided by radical 3 over 2. By keep change flip, we're going to get negative 1/2 times radical, 2 over radical 3. The 2's will cancel out, and we'll be left with negative 1 over radical 3. We got to rationalize the denominator. So we're going to multiply the numerator and denominator by radical 3, and we will get negative radical 3 over 3. That is the cotangent of negative 600. All right, so I'm going to recommend you do all the delta math first for these assignments, but this is what you're expected to do for all these problems.